Sairam students, I welcome all of you once again to the fifth part of lesson number 5, substances in the surrounding, their states and the properties. So, let's recall once again whatever we have learnt in this chapter. So students, in this chapter we have seen that how exactly the substances change their states after they gain the heat or after they lose the heat. So here you can see that over here when we provide heat to the solid substance, the solid substance gets converted into the liquid thing. So when solid thing gets converted into the liquid thing, this thing is called as what? Melting. This process is called as what? Melting. So suppose when we provide heat to the liquid, the liquid gets converted into the gaseous form. So when liquid gets converted into the water vapor, so this process of conversion of liquid into the gaseous part, this is called as what? Boiling. And suppose students, if we provide cold temperature to the gas vapor, means when they lose the heat, the gas vapor again they get come back to the converted into the liquid thing. And again suppose when we provide cool temperature to the liquid thing, this liquid thing again gets converted into the solid thing. So you can see that over here the gas converts into the liquid. This process is called as what? Condensation. And when liquid gets converted into the solid format, this process is called as what? Freezing. So I hope so students, you must have learnt about what do you exactly mean by the boiling and what do you exactly mean by the freezing point. So here you can see that whenever we see any type of the water bubble, whenever we see the water bubbles in the water, when we provide them that heat, so that time we can say that the water is boiling. And you all know that the boiling point of water is 100 degrees Celsius. So at 100 degrees Celsius, the water gets boiled, and the boiling of water, it is also called as what students over here? Ebullitions. Are you getting my point over here? So students, here you can see that over here, when water vapor cools down, again it's converted into the water. This process is called as what? Condensation. And do you know that the condensation of the steam, it also takes place at 100 degrees Celsius. So can I say that the boiling point and the condensation of the water, they both are one and the same thing? So even we have seen that the temperature at which the liquid water get converted into the ice format, that means it gets converted into the solid format. This is called as what? Freezing point of water. And do you know that the freezing point of water is minus 18 degrees Celsius? Are you getting my point over here? So you all know that students over here, let me tell you that when ice gets heat, when we provide heat to the ice starts melting, or I can say that the melting condition of the ice, it is called as a liquid water. Am I right? So when we provide heat to the ice changes immediately into the liquid state again. And ice melts at 0 degrees Celsius. Please students, do remember the difference between that. The ice melts at 0 degrees Celsius and the conversion of the ice takes place at the minus 18 degrees Celsius. So the ice formation will take place at minus 18 degrees Celsius and the ice melts at 0 degrees Celsius. So that means I can say that the freezing point and the melting point of the water, they are one and the same thing. That means freezing point and melting point of the water are 0 degrees Celsius. I repeat once again. Freezing point and melting point of water are 0 degrees Celsius, like condensation of the water. Okay. So guys, can I say that over here, the temperature at which a substance boils while heating is the same temperature at it condenses when it is cooled down. So that means what? Can I say that over here, the boiling point and the condensation temperature is one and the same thing? And as you can see that over here, similarly, the temperature at which a substance freezes, while it is cooling, it is the same temperature at which it is melted down. So that means, can I say that the freezing point and the cooling point of the substance is one and the same thing? Okay students over here. So likewise students, I can say that over here, each substance has a specific boiling point, which is also the condensation point. So the boiling point and the condensation point of water, if we are talking about that is 100 degrees Celsius. but it could be different for different substances. Let's take an example for an plastic. So the boiling point of plastic, it will be different. Let's take an example of the iron rod. The boiling point of the iron rod, it will be different. So depending upon the type of the material which we are using, the boiling point, it will also differ. Are you getting my point, students, over here? And also here you can see that each substance has a specific melting point which is the same as its freezing point. So as I told you that the melting point of water is 0 degrees Celsius, exactly in the same manner I can say that the for different substances the melting point might be different. Okay, so students, the melting point and the freezing point and the boiling point and the condensation point, they all are different for different substances. So likewise students, you can see that over here in this chart below, I have shown that the boiling point and the freezing point of the different substance. So you depending upon the melting point and the freezing point, we can decide that the whether substances are solid, liquid or gaseous at the room temperature. So here you can see that students, the candle. So the first column, it is given substances. In the second column, it has been provided with the freezing point, and in the third column, it has been provided with the boiling point. So the first column and second column, as you can see that over here. So students, can you see that over here, the freezing point of the candle? The freezing point of the candle is 60 degrees Celsius. Can you imagine? So at 60 degrees Celsius, the liquid candle, it will get solidified into the 60 degrees Celsius. And again you can see that over here, the boiling point of the candle, that means wax. Okay, the boiling point of the wax, it is 350 degrees Celsius. So isn't it more as compared to the normal water? So the boiling point of normal water is 100 degrees Celsius, and here you can see that the boiling point of water is the boiling point of the candle, that means wax, it is 350 degrees Celsius. That is, it is too much. And again you can see that over here, freezing point of the plastic, it is less than 250 degrees Celsius, and here you can see that the boiling point of the plastic is almost 954 degrees Celsius, which is too high. Okay, so you can compare students over here. And again see the freezing point of the iron. The freezing point of the iron, as you can see that here, 1535 degrees Celsius. Again look at the boiling point of the iron. The boiling point of the iron is very highest, that is 2862 degrees Celsius. That means from this chart I can say that the boiling point of iron, it is very high as compared to even water or any other substances, isn't it? So the boiling point of iron, it is more as compared to any of the substances. So depending upon the boiling point and the freezing point, we can decide where the given substance, it is solid, liquid or gaseous. Am I clear students over here? So students, as you can see that over here, various uses of the various things are used in the day-to-day life, and they changes their physical state depending upon the substance which we are using. Like for example students, you can see that over here, candles are made by melting the paraffin wax. You all know na, paraffin wax. So the candles which we use in day-to-day life, that is a paraffin wax. Again you can see that over here, solid carbon dioxide. Students, do remember, the solid carbon dioxide is also called as a dry ice. Who is called as a dry ice? Solid carbon dioxide. The solid carbon dioxide is also called as a dry ice, and it is used to make the ice cream and to keep it frozen. So you must have seen that the big container which we use for keeping the ice cream or for ice cream making, the solid carbon dioxide, it is kept. So the solid carbon dioxide, it is very whitish in color and it remains as it is. Okay, and it provides the maximum cooling temperature to the substance. So these are the two substances I told you, candle and the solid carbon dioxide. So you can see that the solid carbon dioxide we use for keeping ice cream, and candles we are using for the decorative purpose, etc., which is made up of what? Paraffin wax. Again you can students see that over here, liquid nitrogen. Liquid nitrogen is used in the animal husbandry. What do you mean by animal husbandry? Animal husbandry, it is a type of the business where we rear the animal. That means we keep the animal for our betterment. Like for example, rearing of the cattle for milk production, rearing of the chicken for egg, etc. So that particular business is called as what? Animal husbandry. So for that purpose also the liquid nitrogen has been used. Again you can see that over here, sand. Do you know that we use a lot of variety of the glass material at home? Okay, so this glass, it is made up of sand. and this sand, it has the silica in that. Silica is one of the element. So the glass which we use at our daily life, the glass is made up of what? Sand. So the sand is glass is made up of using sand, that is nothing but what? Silica. Again you can see that over here, metals like gold and silver are melted to make the ornament. So like we use different kind of jewelry, am I right? We use earrings, we use neck piece, we use the rings, etc. So we are using a lot of variety of the jewelries, right? So jewelry are called as what? Ornament. So the different type of the jewelry we use by making the metals like gold and the silver. So while making the jewelry, the gold and silver has to get melted to give them the proper shape and the design. We want the particular design ornament, right? So to give design to that ornament or to the jewelry, the metals like gold and silver, they has to get melted immediately. Are you getting my point over here, student? And at the same time, as you can see that over here, iron is melted to make the tool. Different type of the tools which we are using for the agricultural purpose or in the mechanical engineering, etc. We are using a lot of variety of the iron tool. So the iron tool are also given particular shape by melting the iron. Okay, so these are the different uses of the metals and the non-metals which we are using by changing their states in our day-to-day life. Okay, so students, as you can see that over here, most of the time you must have noticed that whenever we keep the camphor at our home, you must have noticed that camphor most of the time, am I right? So you must have seen that the camphor smell spreads immediately as soon as we open its box, am I right? And most of the time you must have noticed that camphor, okay, camphor disappears immediately after few days. Have you ever thought that why exactly this thing happens, students? Have you ever thought about that? So the disappearance of the camphor or the smell of that camphor, it is because of the process called as what? Sublimation. Okay, so the camphor, okay, whenever we keep it for longer period of the time, suppose if we keep this camphor for 1 or 2 days in open space, so you can observe that in 1 or 2 days or even might be in the 4 to 5 days, this camphor will immediately disappear. So now you must be thinking how exactly this camphor gets disappears immediately. So the disappearance of the camphor is just because of the process called as what, guys? Sublimation. So now you must be thinking, what do you exactly mean by the sublimation? So let me tell you that, students, what is the meaning of the sublimation? The change of the solid substance directly into the gas. So see, here it is a camphor. Camphor is a solid thing. So when this camphor, it is kept in the atmosphere for the longer duration, this solid camphor, it gets immediately converted into the gaseous format. So this solid camphor, it immediately gets converted into the gaseous format. So this process is called as what, students? Sublimation. Actually, solid should get converted into the liquid and then liquid should get converted into the gaseous format. Am I right? But in the process of the sublimation, the liquid state is not there. The solid part, it is directly getting converted into the gaseous format. So when the solid substance, it is getting converted directly into the gaseous form without changing into the liquid, so this process is called as what? Sublimation. So what is the definition of the sublimation, students? Can you see that over here? The change of the solid substance directly into gas or vapor without first changing into the liquid is called as sublimation. Understood the meaning of sublimation, students? So what we have learned today? We have learned that the temperature at which a substance boils while heating is the same as the temperature at which it condenses when it is cooled down. So that means we can say that the boiling point and the condensation point of any substance, both are one and the same. Similarly, the temperature at which a substance freezes while cooling is the same temperature at which it is melted. So can I say that the melting point and the freezing point of any particular substance is also one and the same thing? Are you getting my point? So guys, here you can see that each substance has specific boiling point and condensation point. So similarly, each substance has specific melting point as well as the freezing point. And what else we have learned today? We have learned regarding the sublimation. So what do you exactly mean by the sublimation? So sublimation, it is that process where a solid substance directly changes into the gaseous format without changing into the liquid. So this process is called as what? Sublimation. Understood, student? So I hope so, students, whatever we have learned so far, you must have understood that. So the next part of this chapter we will continue in the next video. Bye bye, take care.